Cool. That one's working. It'll work eventually. Let me pull up what the first question was. Sorry. Actual. Yes, December 2nd, 2025. Yeah. Giving Tuesday. It's the Tuesday after Cyber Monday. It's supposed to be like the capitalistic response or anti-capitalistic response, I guess, to like all the just buying shit holidays. Only 1 hour tonight. Sorry, fam. Yeah, I have a busy schedule because I got a lot of people that needed private tutoring today because some teachers are being mean and they're putting exams right before Thanksgiving, and then also I had a lot of stuff I had to like take care of with my other job. So it was scheduled to start at 3 today. Correct. Yeah, I had to push it up. So instead of being 3 to 6, it's 5 to 6. 5 to 6:15 today. Yes, I do have to make money. Yes. Unfortunately. But that being said, we have questions in the queue. Let's see what we got. Nice. I like this. Ooh, scattering? This is cool. I want to paste today. Yeah, because I haven't determined the exact start and stop time yet. I'm talking with Zach and Penn Center later about that because I think we're gonna try to maybe collaborate on that as well. So that's why I haven't. It's gonna be on that day, but the exact start time and end time haven't been set yet. So just keep it on your radar that December 2nd there will be something. All right. I need this chat to work, please. Come on. There we go. Okay, cool. And then where's my admin panel? No, it's not there. I just found out a great court. Oh, Sean Carroll. Oh, nice. Oh no, they're dropping them. Oh, that sucks. Oh, that's terrible, dude. What? No. That sucks. Okay. A photon of wavelength 0.02150 nanometer strikes a free electron at rest and is scattered at an angle of 70 degrees from its original direction. Compute the wavelength of the scattered X-ray in nanometers. Okay, cool. Now, does the scattering angle like matter? What is this called again? I think this is called Compton scattering. You know, it's funny. I was actually just writing a textbook for a modern physics class in this stuff. Yeah, I think this is Compton scattering. There's a formula for that. Oh, here we go. Yeah, but I want something with the angle. Oh, there we go. This is what it is. Yeah. Straight out of Compton scattering. Yeah, I guess so. Yeah, it is Compton, right, fam? Yeah. Okay. So this is the equation. So Compton scattering is, when you blast like electrons with photons. And then so photons are massless, like light particles is kind of what we think about them as. But they do contain energy, and they do have the ability to like knock other things that have mass in different directions. And so yes, they will get deflected at a certain angle. This is cool. So theta is the angle at which the photon is scattered, and then phi is the angle at which the electron is scattered. He was handsome. Was Compton? Was he a handsome guy? I'll look it up. Yeah. Odin, if you want to give me the formula sheet, I assume you're given this. I think this is what you need here, right? I think you need this. Because there's a shift. So the photon originally has this wavelength, but then by virtue of it knocking into the electron, it's going to lose some energy, which means it has to lose energy, which losing energy, if we remember it right, E is equal to HF, which is equal to HC over lambda. Losing energy means increasing in wavelength. Yes, okay. So this scattered photon has to have a positive shift in its wavelength that represents losing energy to knocking the electron. So, H is a constant, I think. Or do you have an exam on photons and oh man, dude, wow. That's rough. See, yeah, dude, isn't that whack, dude? What? You have an exam like right before Thanksgiving? That's terrible. Okay. Are you dropping the formula sheet for me here? Or just let me know where you're dropping it. I think we're just gonna do this, but alright, I need to find we need H over MEC, which I think this is something special, right? Is it like Compton? Oh, the office hours channel. Oh, okay. Where do we find that? Cool. Okay, this is the formula sheet you get. Relativist. Oh yeah, there's all this fun stuff. Okay, cool. No, you get this equation. This is Compton scattering. Yeah, you're good. Okay, I just need these constants. Let me figure them out. Compton's scattering constant electron. There we go. This is I just want it. Is there a value for this? Can I just get it? Okay, here we go. So H over MEC is 2.4 times 10 to the minus 12. You also added the constants. Okay, thank you. Okay, cool. Yeah, and this is the exact one I was looking for, actually, right? There you go. Yeah. So that is this, right? That's the H over MC. So 2.4 times 10 to the minus 12. Cool. So yeah, so you have delta lambda is equal to 2.4 times 10 to the minus 12. And then that's going to be 1 minus cosine of, and what'd they say? 70 degrees from its original direction. So that's theta. So cosine is 70 degrees. Yeah. Not bad. Where's my calculator? Fix this. Much better. Calc 3. Yeah, is there a lot of Calc 3 tonight? Fuck. Alright. I may stream later tonight after I'm done teaching to try to help out with those questions. If there's a lot getting put in, I might do a late night stream tonight. Let me see. I do have to go tutor someone in person in 58 minutes. But after that, I may still have energy to like do more. Okay, so let's do this. So 2.4 e to the minus 12 times 1 minus cosine of 70, right? Make sure we're in degree mode, by the way, too. We are good. Okay. Oh, god damn it. There you go. Okay, so that's 1.58 times 10 to the minus 12. Okay. So I'm going to divide that by 10 to the minus 9. Because I want it in like nanometers. So that's equal to 0.00157 nanometers. Okay. So that's how much the wavelength increases, by the way. Okay. So you have to add this to this to calculate the new wavelength. So new wavelength is equal to this plus 0.02150. Great. So you get 0.0230 nanometers. Okay. Nice. There we go. We got that one done. Yep. Damn, probably in geometry. Yeah, we have people from all sorts of different walks of life in questions, so it's all good. Find the energy gained by the electron. Oh. Well, that's the amount of energy that's lost by the photon, right? I think that's how I would do that, yeah? Because by energy conservation, it's got to go somewhere, right? So I would say energy lost from photon is equal to energy gained by the electron. And the energy it lost, right? So delta E for the photon is equal to hc over delta lambda, right? So what is that? Oh, and they want it in, here's a cool thing. They want it in KeVs. So when I see my constant for H, I'm going to use this one. Because this one's in EVs. Also has C attached to it, which is nice. W. And also in nanometers. Oh, beautiful. Okay, cool. So this is just going to be 1240 EVs. EV nanometers, right? And then that's divided by this 0.00157 nanometers. Because then nanometers cancels. Love that. That's actually kind of fun how that works out. So I'm going to do 1240 divided by that delta lambda we got. And I'm going to divide it by 1,000 for kilo. Cool. So you get 785 keV, I think. Does that seem about right, Odin? I think it is. I don't know much about electron scattering, honestly. I haven't really done most of it. I don't have much of an intuitive knowledge for it. Okay. I think it is. Let me make sure this is right, actually. Sorry. 0.0015. Yeah, right. Okay. Oh, wait a minute. I don't think I can put delta lambda here. Sorry. Let me fix this. Because this is kind of it's like a calculus thing, actually. So yeah. Sorry, you can't just put delta like that. Sorry, I did mess up. Okay, delta E the photon is going to be energy final minus energy initial for the photon, which is equal to hc over lambda 1 or lambda final minus hc over lambda initial. Yeah, it's not just delta, sorry. Because these are in the denominator. You can't just put a delta there. Sorry, my bad. So this is 1240 EV nanometers. And then this is over the 0.0230, right? Yeah, I was looking at that. I was like, this is kind of high, honestly. And then the original wavelength it was at the 0.02150. Okay. Yeah, my bad. You can't just apply delta across denominators like that. Because it's inversely proportional. It's not linear. 0.02150. Okay, Odin, does that make sense? So, yeah. Sorry, I gotta do 1240. I just wanted to put the delta there. But you can't do that. You can only do that if it's linear. It's inversely proportional.
Nice.
I make mistakes too. Especially today, dude. My brain is burnt. There's so much I've been doing today. I still have so much more to... I gotta go teach another 2 hours after this. Great. Okay, there we go. So, that's like... So divide that by 1,000. Because we're all struggling right now. Thanks for the follow, Sarah, by the way. Appreciate it. Yeah. It's okay. The struggle makes magic, you know? That's what I say. I will say I'm also... So this is around like 3.8 keV. Okay, cool. That sounds better to me.
Bing bang.
Okay. Let the outgoing electron suddenly be stopped by a metal target and lost all its kinetic energy. And all its lost kinetic energy produces a single photon. Calculate the wavelength of this photon. Okay. So, I mean, that's just taking this. So, 3,800 EV equals HC over lambda, right? Okay, so you just redivide. And that's in nanometers, yeah? Oh, okay. So, that's just 1240 divided by the 3,800, right? Okay, so you get like 0.32. 32 nanometers. What's up, Poison? Okay, nice. Cool. That makes sense. Odin, how we did that? That's part C. Part C. Part B. Part A. Why are units cooked? Yo, what's up, JC? Yeah, look at all these units, dude. Look like EV nanometers. Like what? Get out of here. Okay, nice, cool, great, awesome question. Good job.
Well done. Well done.
Because the point is to trip you up. Yeah, I mean, it's definitely annoying. Yeah, units, but units can be cool also because they help you kind of see what the equations are. Especially if you're taking standardized tests, sometimes you can eliminate answer choices by just like looking at units. What's up, MZs? So I know they're annoying to especially when all the constants can be written in so many different units.
But they are useful. Yo, what's up, Poison? I have the squeaky voice on now. Okay, let's see what do we got next. SB1214. Vector field, great, love this. Yeah, this is great. Cool. Yeah, Poison, you got me with my squeaky voice now. It's my mouse voice. Just for you, dude. Okay. Consider the vector field fxyz is y x minus 4z. Well, this is kind of weird. Wait, sorry, what?
Are they saying like y I plus x j? I think they're doing this, right? Minus 4z. Okay, I think that's what they're saying. Show that f is a gradient vector field. F equals grad v by determining the function v which satisfies. Wait, that's f. Which satisfies v of 0, 0, 0 equals to 0. Oh, okay. Thank you. What's up, Odin? Okay. Is this where I just do like all the like the reverse integrals and stuff? Not reverse integrals, sorry, like component integrals. And then that's an initial condition then, right? So, okay. So, fx is equal to y, and that's equal to dv dx, right? And then fy is equal to x, and that's equal to dv dy. And then fz is equal to negative 4z. And that's equal to dv dz. Okay. So then what you can do is you can move all these things over. So then you get that dv is equal to y dx. And then dv is equal to x dy. And then dv is equal to negative 4z dz. Cool. So now you can just integrate. Integrate. Oh, I see. We're gonna figure out what the constant is. I see how this is gonna work. Okay, so this tells me that v is equal to, so the integral of y dx is just yx, but then that's also plus like a function of y and z. This tells me integral of x dy again is yx again, so that's kind of nice. So that's equal, so plus like I say like h of x and z, and then this is v is equal to negative 2z squared. Mathematician, hi, do you have any tips for tutoring and helping others in math? being patient, I think. Also, like, checking with people. It's a little bit harder online, especially on this format, because I don't have someone, like... I can't, like, talk to someone directly. Or, there's not as much of a response. But, like, there's a delay. In general, when I teach in person, I'm always being like, does this make sense? Does this make sense? But also, like, I can really tell when someone's, like, just saying it to say it. Or if they actually understand what's happening. You can't see the queue on TikTok? Also, yeah, wait, why is my chat not working on TikTok? Sorry. Dude, TikTok's been fucking up recently. There we go. Let me see if my chat's working this time. Abstract algebra, I can't directly, but there are people in my stream who can. So yeah, please feel free to like drop the question in the queue. If you want to see what the queue is, go to actualofficehours.com. That link down there will have the queue. Okay, so this integral of -4z is z squared over 2, so -2z squared, and then this is plus a function of x and y.
Nice.
Cool. So then I just see, like, what satisfies all of this. Well, v is equal to xy, right? See how that's in common? That's in common. Minus 2z squared, and then we say plus c. And this is the constant. But what I do know is that at 0, 0, 0, this needs to be equal to 0. Which I think it is, right? 0, 0, 0. Okay, cool. So actually, yeah. v of 0, 0, 0 is equal to 0 times 0 minus 2 times 0 squared plus c. So c just equals 0. Can you go through all the medical terminology on the muscle system? No. What? Excuse me? I actually don't really know much medical biology stuff. Because a lot of it's just memorizing or just looking shit up. Is this shit the SAT? No. This is, I think this is Calc 3 is what this is. But okay. So, so for those that are watching, like, a little confused at, like, what this is, like, this inverted triangle thing, this is called nabla. So, there you go. Globus is super cool, I guess. His mod is kind of a dick, though. Who? Globus. Sorry, I didn't see that on the chat. I'm sorry. My bad. Also, you're a VIP fam. You should be able to say whatever in my chat. I don't know why it held it. But anyways, so this delta here. So nabla. Do I believe in aliens? Yes. I got xy minus 2z squared. Yeah, that's what I got as well, Femfox. Nice. Oh, I appreciate that, Bishlama. Yeah, I'm pretty good at math and science in general. I have the PhD in physics. So this nabla thing here is the same thing as like ddx, like comma d dy, comma like ddz. It's like a 3D derivative operator is what they call it. It's like a 3D derivative. So basically, for these questions, start off with taking the parcels for each term. Exactly. So when you operate this, like this on a function, what that does, or in this case, sorry, on v, right? This takes dv dx and makes it the x component of a vector. This is dv dy, and then this is dv dz. And this whole new thing here is a new vector f, okay? So taking the gradient of this is considered a scalar. It's a scalar because it doesn't have components. It is equal, when we figure it out, it's xy minus 2z squared, right? This is still scalar because it doesn't have any direction to it. I know it has like x's and y's and z's in it, but those are variables. Those are not directions. When stuff is written out with like commas like this, or for instance, if they say like dv dx and then they would say like I vector, that's really what this is. It's dv dx pointing in the x direction. This is dv dy pointing in the y direction. And this is dv dz pointing in the z direction. And that's why f is a gradient vector field. Yeah. Yes. Yeah. So I took the integrals of each. So yeah, so once you know that, okay, well, this part right here, right? That's just the x component of f. And we know that Right. So I say the x component of f, which is dv dx, has to be equal to. In this case, it's y. It's funny why they wrote this. They shouldn't write it like this. This should at least have been a bracket, or they should have said, or they should have written it how I did here in terms of unit vectors, which is y I vector plus k j vector minus 4z k vector. What's up, Alistair? Yeah, and you integrate each term. Yeah, so you integrate this one by like just like putting this over here, and then you have dv is y dx, dv is x dy, dv is negative 4z dz. And then you have like 3 different integrals. So this is like all the parts of it, and you're kind of doing like, I mean, it's kind of like least common multiple maybe, or something, I guess, because you're seeing like what v like has all the components of this. So v needs to have yx plus something that could be a function of y or could be a function of z, or both. And then it needs to have xy plus something that could be a function of x or could be a function of z. And then it turns out that function of z is this part, the negative 2z squared. And then you always need to put a plus c at the end, because there could also just be constants that are numbers. And then that's why we have this condition here, v0, 0 equals 0. I plug in for, you know, x, y, z, and now I can solve for c. Yeah. What's my favorite element? Come on, you guys know that. You don't understand this as a calculus student? That's okay. This is vector calculus. This is Calc 3. You haven't gotten to this yet. You should understand derivatives, right? And you should understand integrals. It's just doing it in a couple different dimensions at the same time. Damn, my prof went through this entire proof thing and it made no sense during lecture. Yeah, typical. Well, I hope this makes sense. Yeah. Honestly, the problem is like math professors sometimes are so specialized and high up with their knowledge that they forget how to explain things in like simple terms, and they just make it all like complicated for no good reason, and then like it sucks. So I totally understand that. I empathize with you. Yeah. Breasticles, I always forget like the difference between like a partial and a full derivative, but like whatever. Mathematician, what's the highest amount of money you earned while tutoring? That's a good question. I think I had a kid pay me $300 an hour once. They were really desperate though, and super rich. It was like the night before like their final exam, and they like booked me like last minute, and I was like, my rate's $300. Like I don't do this very often. Like I don't take like last minute calls at 11 o'clock at night because you have a final the next day. But they said they would pay it, and I was like, fine, I'll come help. All right, anyways, good question, SB4. Did they pass? I think they did, actually. I would hope they did for $300, right? And, you know, I always, like, prefer, you know, I'm very upfront with that. If someone is booking me last minute, I hate when I get booked to tutor the day before a test. Because it's just not fair to the student. It's also, like, kind of not fair to me because I'm, like, kind of set up for failure. It's very hard to, the day before a test, like, perform a miracle like that. And I don't feel good doing that. I don't feel good failing. So I tell them straight up, I'm like, yo, no promises here. Like, it's the day before a test. There's only so much I can do. I will try my best. Like, don't get me wrong, but also don't get mad at me if it doesn't work out. And they always say, like, oh, we don't care. We're just happy we can find somebody to agree to this. And I'm like, okay, cool. Then we're good. Like, you know. Yeah. Yeah, MCQs. Yeah. Yeah. The MCQs suck because you don't have any partial credit. And MCQs are honestly just because teachers don't have unlimited time to grade FRQs. So they have to put in MCQs to give themselves, you know, somewhat of a break on the grading. Anyways, good question, SB. Thank you, Troll Cats. Yeah, no, we had a short stream today. I only had an hour and 15 minutes today. Let's see what we got next. Calculus knee growth. Knee growth? God damn it. You guys getting me to say things. Knee growth? Fucking fuck. Anyways, okay, here we go. Yeah. Ain't no way, dude. If we want to get like if you want to get pedantic about it, like the way to say black in Spanish is negro. Like it's a real word. I think we're past the point of canceling people, right? For like unintentional slips, right? Okay. Compute this for the upper half of the ellipsoid. Oh fuck. Jesus. This is gonna be tricky. What part of Moreno means dark. Black is definitely negro. In Italian, it's nero. Yeah, what the fuck is a Z component, dude? Go home. You're fucking drunk, dude. What? Sine of E to the R? You just want to apply divergence. Yeah, this is the divergence theorem, right? Isn't it? Yeah. All right, let's go find. You think it's in spherical? I'm tempted to say it's in cylindrical, right? Because I see x squared plus y squared, which is always r squared, right? This is curl, yeah. But no, curl can be written as divergence. Right? Isn't that the divergence theorem or something? Or am I thinking Green's theorem? Sorry. No, you're right. No, I'm sorry, I'm wrong. Is this Green's? Is it Stokes? Sorry, is it Stokes' theorem? No, here it is. Here it is. Here it is. It's Green's theorem. Yeah, curl, cross, div, dot. Yeah. Okay, I think it's this one. Yeah, because this is what I'm doing, right? Because dA is also and it's Green's theorem, right? Yeah, this is Green's theorem. Bro, I got vector fields and line integral exams tomorrow. TikTok knows, dude. They know exactly what we're doing, dude. Okay, the curl theorem over a plane. But we're not really on a plane. This is not a plane. This is a fucking ellipsoid. Do I have to parameterize this? Fuck.
Nice.
You guys hit me with the hard ones. It's not about the plane necessarily, but I assume I need to go around it though, right? Why does it keep opening my LinkedIn? I don't need my LinkedIn. Sorry. It's Stokes' theorem. Okay, thank you, JC. We're looking at the wrong theorem. Yes, here we go. Uh-huh. Yes. Green's is just 2D Stokes, yeah. All the JC's great, yeah. Yo, shout out to JC, by the way. Yeah. Alright. Let me paste in what like Stokes' theorem is. This is literally the class I'm in right now, yeah. So yeah. TikTok listens to the transcription of everything I say, like in my stream, and it'll start showing you, it'll start like targeting my stuff towards people who are doing this in their class. It's very interesting. I think it's actually a really cool part of TikTok's algorithm. It's kind of creepy. This is not linear algebra. Is it linear algebra? This is vector calculus, I'm pretty sure. So let me get this question again. This is it. This is Calc 3. Okay, the ellipsoid. I think I want to do this in... Right, okay, so do I just need to go around the ellipsoid? Okay. The upper half of the ellipsoid. Let me think about this. Oh, wait. Z is greater than or equal to 0. Oh, wait. I think I know how we do this. Yeah. Okay. Yes, yeah, exactly, JC, so right, yeah. This actually, okay, so this is the cool thing about Stokes' theorem. Is that, so an ellipsoid, right, kind of looks like an egg. It's going to be like, can I draw that correctly? I can't really draw it. It's like this. It's kind of like this. Right? And then it does this, and then it does this. So one thing to do is yeah, I could take the curl of F, where this is F, but this sucks. I don't want to take the curl of this, especially with this like fucking nasty shit happening, right? So I could take the curl of this and then dot it with n this d sigma here is like the surface area integral of it. Okay. That's also equivalent though to just doing the contour integral of f dot dr around the boundary of it. And the boundary of it is here. That's what JC was saying. The boundary is where z equals 0. So instead of doing all the cross product or all the curl integral across the surface of the top of this egg, I'm just going to do the path integral around the sides, right? And so this occurs at z equals 0. So that means that 16x squared plus 25 y squared is equal to 400. Okay. This is an ellipse. That, let's see how you can do this. Do you divide by 25, I think, right? Yeah. Or divide by 400. Oh, sorry. Yeah, I want this to be equal to 1. Thank you, Jose. Yeah, let's do that. Divide by 400. Divide by 400. Okay. So you get 16 over 400, which is equal to what is that? Is that 25? Oh, it is actually. Oh, wow.
Good job.
Oh, wow. They kind of come out to each other. That's kind of fun, actually. Okay, so you get x squared over 25 plus y squared over 16, right? Is equal to 1. Oh, okay. Right. And this means that the semi-major axis, the semi-major axis is equal to 5 then, right? Because this is like a squared and this is b squared. Oh, interesting. Okay. So then, what's the parameterization? Okay, let's work a little bit backwards here first. Sorry. I have f, right? Which is this, and then I need to do it like dot dr, right? But since the dr we're looking at is in just this direction, right? Dr is just going to be equal to ddx. Or sorry, dx, right? It's dx comma dy comma 0. Because the infinitesimal line segment thing we're doing only points in the xy plane. Right? So this is dr, which is great. Because when I do f dot dr, like, yo, dude, fuck this z component. I don't even need it. Right? This is where this is beautiful. This is where, like, Stokes really makes me happy. Because this is in vector form, right? This is y, comma x squared, comma fucking garbage. But when I do f dot dr, I don't care about this because the dot product will just get rid of the z component. Beautiful. Okay. So now I have the integral of y dx plus x squared dy, right? But then we need to do that, but now we need to reparameterize this. Okay. And that's where this happens is, okay, so instead of trying to figure out how like dx and dy are changing in terms of x and just x and y. I can describe this as, I think, something in terms of just theta, right? Is there what's the parameterization for an ellipse? What's up, the endo? We're doing some Stokes theorem. What's up, midget? Parameterization of a ellipse. That message was so Midwestern. Okay, here we go. Yeah, it's a cosine theta, b sine theta. Where I think a is gonna be in this case 5, right? So from the equation of ellipse, right? It's x squared over a squared plus y squared over b squared is equal to 1. So in this case, a is equal to 5, b is equal to 4. Good. Yeah. Okay. Great. Okay. So then, okay. So we're to here so far. So by ellipse parameterization, x equals 5 cosine t, y equals 4 sine t. Oh, very cool, Breskles. I'm half asleep. Okay, welcome, dude. Okay, cool. And then t is gonna go from 0 to 2 pi. Okay, cool. Now we got a parameterization. Nice. Okay, so if that's x and that's y, then dx is equal to -5 sine t, and then dy is equal to 4 cosine t. Beautiful. dt, right? Yeah, sorry, dt. Don't forget the dt's. Nice. Okay, so now we have the integral from 0 when the sine what's the sine? So we have 0 to 2 pi, and so this is going to be y. And then remember y is equal to 4 sine t. So that's 4 sine t. But then dx is -5 sine t dt. And then this is plus integral from 0 to 2 pi x squared. So that's 25 cosine squared. Cosine squared t. And then dy is 4 cosine t dt. Okay, cool. So this becomes -20 sine squared t dt from like 0 to 2 pi plus 100 cosine to the third t dt from 0 to 2 pi. These are kind of messy integrals. I know this one I can do with the double angle, right? Right? Because this is sine squared t is yeah. What's integral? Wait, I'm just gonna look these integrals up. You can do it with the double. It's this one, right? Yeah, sine squared is equal to 1 minus cosine 2 theta over 2. So then you can do this, but where's just like the answer for it? I just want it. I don't want to actually go through and do it. There we go. That's what I want. Yeah, nice. Also, just in the interest of time, I think the hardest thing is setting up this and getting the integrals. Doing the integrals is whatever. Okay, and then what's cosine to the third t? What is 0? What's cosine cubed of x? Cosine cubed of x is... Hey, brother, how are you? Where are you from? I'm from Los Angeles. Or wait a minute. Oh, this just goes away, actually.
Huh?
This is odd. This is odd parity. Yeah. Odd over 0 to 2 pi. So that integral just goes to 0. This is a trick you learn. Los Angeles. Los Angeles. Okay. So then this one is negative 20 times 1/2. And then it's going to be 2 pi minus, well, sine of 2 pi is just 0. So that just goes away, right? Okay, beautiful. So then I get, I think I just get negative 20, right? The 1/2 and the 2 cancel here. So you just get negative 20 pi. Nice. That actually looks pretty nice. I'll take it. Cool. Good question.
That's dope.
Wow, that's kind of an interesting one.
Well done.
Giovanni's a very Italian name for Los Angeles. Yeah. My mother's Sicilian. No, this is Calc 3. This is not Calc 2.
Nice.
Boom, boom, boom. All right, let's see what else we got. Sephiroth. Wow, there's so much Calc 3 today. Oh man, I'm getting a crash course in Calc 3 today. Jesus. Okay. Consider the solid bound. So this is a sphere. Yeah, I love cylindrical coordinates. I do cylindrical coordinates all day. Calc 2 and Calc 3 is just multiple variables.
Nice.
So Calc 2 you do integrals mainly just in terms of like dx or dy, and then Calc 3 you start doing them in terms of like dx, dy, and dz all at the same time. No, actually, please do crash course. It's rough out here. It is rough. Okay. So this is a sphere. We should know this is the equation of a sphere, right? But don't worry. Yeah, no. Luckily, dude, there's so many resources out there, such as this stream, that like you don't have to struggle as much as I had to when I was in vector calculus. So you got a sphere, and it's bounded below by z equals 2. Interesting. Okay, so fascinating. So they want to bind it from here, I guess. Or here, let's get like a. Is this gonna be like another ellipse? No, right? No, this is another circle. This is at z equals 2. Yeah, okay. Write an integral that gives the volume. Oh, so this is actually, sorry, this is this is Calc 2 maybe. It is a big ball.
Oh, yeah.
Big ball. Okay, so in cylindrical coordinates, right? X squared plus y squared is equal to r squared. So that's like the circle. And if x squared plus y squared plus z squared equals 16, so x squared plus y squared plus z squared is equal to 16. That tells me r squared plus z squared equals 16. Or that r squared is equal to 16 minus z squared. What's his process for teaching himself the material? I mean, I know some of this, honestly. Already. I just have, I Google stuff to, like, remember things. Is it, Jorgen? My buddy's working on, like, an algorithm for it. Actually, sorry. So, no, let's put this in terms of z, right? Yeah. Let's say that z squared is equal to 16 minus r squared. So z is equal to the square root of 16 minus r, plus or minus, right? Depends where you are. Oh, so that, I think I have to break this up into two different integrals then. Right? Okay, so if we were to do this in cylindrical coordinates, which cylindrical coordinates I think is like r, dr, dz, d theta for cylindrical. Oh, for research? Yeah, my buddy's doing like kind of an AI for research thing. He's a quantum gravity physicist. So this is dv in cylindrical coordinates. So let's think about this. So I think I may want to reorder the integrals. No, actually this is okay. D theta is always going to go from 0 to 2 pi, right? That's always nice. This is easy. I think how we do dz and dr has to be a little trickier though. So let's think. I think z is going to go from negative... Okay, no. So let's have r... Oh, man. R is going to go from at the biggest being out here, which is going to have an R of 4, right? The Jacobian matrix gets you your D terms. I think logic is pretty cool. I've done a little bit of logic. Okay, so this is 4. Oh, let's figure out what this is then. I feel like I want to integrate in terms of z and then get an equation from r. Alright? Yeah, no, let's do it this way. I want to do z from negative 4 to 2, right? Let's do that. Negative 4 to 2, yeah? And then we just need to come up with an expression for what r is. Yeah, so, yeah, no. Let's do this in terms of r. I want to do this in terms of r. R squared equals 16 minus z squared. Wait, what language? Is that Greek, dude? What are you writing in Leckle, dude? What? Okay, so r is equal to plus or minus the square root of 16 minus z squared. But r is always positive. You can't have negative r's, right? Okay, so then I think we want to do this. So as we go from... Yes, and then this goes from 0 to the square root of 16 minus z squared. Bounded below by z equals 2? Oh, so is it from 2 to 4 then? Sorry, I thought it was below z equals 2. Oh, no, you're super right there. Sorry, fam. Yeah, thank you, fam. Yeah, sorry. The bottom of it is at 2. The top of it is at 4. Yeah, 2 to 4. Okay, then I think this is fine. Okay, great. Nice. What's the difference if I integrated pi r squared dz? You can't do that. Because technically there's like curvature here. Like you're missing, as you like try to keep stacking circles like that, I think you miss like some information in the curves. I think so. So you're saying, for instance, if you did pi r squared, and then what? Sorry, dz, but then and I guess technically, if you're doing for a sphere, like you're saying for a full sphere, in that case, like dz would go from negative r to r. And then r squared is 16 minus z squared. Oh, okay. But it would go from minus R to R, right? Yeah, but R varies as Z varies. Yeah. Oh, very interesting. Well, I'm saying like from big R to big R, right? I want to see if you get the same 4/3 pi r cubed, but I don't think you do. Hey, you don't, right? Do you? Well, let's see. So that's 16 pi Z. So that's 16, all right, times 2R, right? And then that's minus pi Z the third over 3. So then that becomes 2 big R cubed. That's the wrong square root for negative Z. Oh, I see. Yeah, because they have to change it. Yeah, I don't think this works, though, JC. I don't think it does. I remember that, like, you can't do just, like, discs when there's, like, there's so much, like, curvature happening everywhere. You start missing out on information. I think this is the way you have to do it. Yeah, oh, we're not evaluating. Yeah, figure out why. Yeah, look at it. Yeah, look into it. Yeah, it doesn't work, I think, because of the curvature. It's the same reason when you do, like volume of revolution type stuff. If you're doing, like, this, and you want to, like, just build, like, a bunch of disks, like, that's kind of cool. But then it's, like, instead, you have to do, like, square root of 1 plus, like, f prime of x squared or something. Like, dx. Less than 10 minutes, you got it. Yeah, sorry. So I do need to finish this. Okay, spherical coordinates. Depends which... So this is a math class, I assume, right? So what's the convention for that? Yeah, but it's at like... But it's... which one's phi and which one's theta? Oh, not cylindrical, sorry, spherical. Yeah. Like, is this the one? I always get confused which one we use. Yeah, sorry, no, these were cylindrical coordinates. Theta is outside. Okay. I do agree with theta is outside. What's up, Machka? Thank you. Okay. So then Z, I think, is equal to, what's that? R cosine phi? Yeah, right? This is Z-axis? Okay. So E equals R cosine phi. X is equal to, like, it's like R sine phi cosine theta, right? You did it the physics way? Yeah. I think this is it, right? Yeah. Thanks for the follow, gamer, by the way. Dun-dun-dun. Not R rho. Okay. You're right. Technically R refers to this. Can I be lazy and just write R for now, though? I hate writing rho. It's like a weird P. Okay. I mean, R is equal to 4, right? But then we have to put this... there's a restriction now in Z. Fuck. Okay. If Z is equal to 2, so 2 equals R... 2 equals R cosine phi. Yeah, you would be a millionaire, $5. Okay. So I need to figure out like what phi this happens at, right? So, okay, so R is equal to 2 over cosine phi. And then like where does this happen? Oh, but R equals okay. R is equal to 4 then, right? Like that's the maximum it can hit at, yeah. Trying to think here. Yes. That would be, for instance, when we're at here, let me draw the thing. If this is the sphere, then at the edge boundary, right? Like right here. This R is still, or rho, whatever. R is equal to 4. And I need, okay, I need R cosine theta to equal, okay, I think I got it. No, this is math, it's math. Not physics. Okay. So 2 is equal to 4 cosine. Let's say like, I see. That's going to be like my phi 1. Because that's going to be the phi I start at. And then I'm going to have everything else go down. Oh, very cool. Very cool. I think I get it. So 1/2 is equal to cosine phi 1. So that's what this is. This right here is going to be like phi 1. And then when we do our integral or spherical integrals, we're just going to do from this down to negative pi over 2. What's up, Humanity? This is Calc 3, yeah, for sure. Oh, okay, so phi 1 is equal to arc cosine of 1/2, and that's equal to pi over 3. Very cool. Okay, so wait, now I think we're done. I think we're done here, right? This is easy. So let me do d theta, right? So theta is going to go from 0 to 2 pi. And what is dv for spherical? Exactly. Yeah, Femvox is right. Here it is. Oh, but this is the physics way. No. Oh, no. We need to go find the other one. Sorry. Oh, shit. I think it's this one. Yeah, it's this one. This is the math way. The thetas and phis being backwards is such a pain in the ass. The math notation is better. No, yes, because xy is usually theta. You're right. It's just, yeah, I get you. I understand where it's coming from. Okay, so this right here is d theta. Okay. And then in terms of d phi, right? D phi is going to go from pi over 3 all to negative. Oh wait. Sorry. Sorry. I keep getting this wrong, Femvox. I don't want this area. I want this area. Okay, so I want from 0 to pi over 3. Got you. Okay. And then, well, the radius is then dependent on theta, right? So we're going to go from a maximum radius. We'll be out at 4, right? That's when we're here. And then the minimum radius will be, oh, whatever the z coordinate is. Okay. Yeah, so that's 2 over cosine phi. That's from this, right? All right, where was it? Where is this? Right, from here. Right? Yeah, okay, here we go. Right. This is the minimum R. And then this is the maximum R. Yeah, I don't know. Okay. All right, and then this is R squared sine phi. That's like the Jacobian part of it. Okay, nice, cool. We did it. Nice. Good job, guys. No, it's kind of hard. Good question, Sephiroth. Wow, thanks, Sam. I'm about to end the stream. Okay, sorry, I gotta go. Let's close the stream. Alright, thank you everyone for coming to Actual Education Office Hours today. I know we had kind of a shorter stream today. I have a lot of other students I have to teach today, unfortunately, but I wanted to make sure to at least give some time to help you guys out. Anyways, but we are going to be streaming tomorrow, so, and do not worry, if we did not get to your question in the queue right now, go to this website, actualofficehours.com, because there you can join our Discord, and every question I didn't get to today will automatically get transferred into our Discord, where either I will go over it or one of the other awesome actual educators on my Discord will if they have time, they'll go through it as well, or another stream. Riot in the streets. I know. I'm sorry, guys. But again, if you want to check out the streaming schedule as well, this is all the other times that we stream. So we will be on tomorrow, starting at 3 p.m. Pacific. But also Zach and Penn Center are doing a special event. What are they doing? This is their podcast. 10 a.m. tomorrow. Make sure go say hi to them. They're awesome. We love them as well. Let me say E to the 2i pi. Yeah. So go check out Zach's podcast tomorrow at 10 a.m. Otherwise, we'll also be helping out with math and science questions starting at 3. Okay, that being said, if you're watching us on Twitch, which I highly recommend, again, if you go to the website, actualofficehours.com, and you found us on like YouTube or TikTok or something, go click here to go watch us on Twitch, because first of all, it's a way better format. It's horizontal. It's easier to see. And also, you can join us in a raid where we're going to go support another streamer who's on right now doing math or science or something. So who's on these days? Interesting. Nerduino. Let's go say hi to Nerduino. I love Nerduino. He's a great person. Okay, go say hi to Nerduino, another fellow science streamer. Have a wonderful rest of your weekend. We will see you guys tomorrow. Peace.
Unfortunately. So, didn't happen. Allegedly. Mr. Vincent Astro allegedly was trying to... Actual education! Actual education is in the house. Welcome in, Actual Education, guys. Make sure you go follow Actual Education, an amazing streamer here on the platform. I got to meet Actual Education at TwitchCon. He's wearing a very spiffy gold jacket. Best dressed at the con, I would say. Best dressed at the con. IRL hangs, yeah. And next year also for sure. And there could be more IRL hangs in the upcoming, because we don't live that far away from each other, as we discovered. So if we look outwards and see the origin of the universe, that's if we look inwards and see the end, global warming might just be it could be Nick Baring, yeah. It could be. Raiders, welcome in. How is your Femvox fam? Welcome in. How you doing?